cross product another type of vector multiplication. Unlike the dot product, which gives us a number, the cross product A cross B will give us a vector of magnitude of A times the magnitude of B sine theta AB, the angle between the two vectors. Also, the cross product can be found by solving this determinant, but I will not solve the determinants. I will use another method, but it is the same as solving this determinant. So A cross B give us a vector. This vector is normal to both A and B. The cross product AX cross AX or AY cross AY or AZ cross AZ will result in 0, because AX cross AX, these two vectors have the same direction. They are the same vector, so they are the same direction. The angle between them is 0, and sine 0 is 0, so the result is 0. But if we take AX cross AY, it will give us AZ. AX have magnitude of 1, AY have magnitude of 1. Sine theta, the angle between them is 90, so sine 90 is 1. The magnitude is 1. A vector perpendicular to both AX and AY is AZ, but also it can be minus AZ. But how to determine this one? How to determine if it is AZ upward or minus AZ downward? Just write X, Y, Z, the coordinates, the variable in the Cartesian coordinates. If we move from left to right, it will be positive. If we move from right to left, it will be negative. So AX cross AY, AX cross AY, we move from left to right, will give the other variable or the other dimension AZ, and it will be positive left to right. Also Y to Z, AY cross AZ will give us the remaining dimension AX. It is positive because we move from left to right. AZ cross AX, AZ cross AX will give the remaining dimension AY. It is positive. If we move from right to left, AY cross AX, AY cross AX will give the remaining dimension AZ, but it is minus. Right to left is minus. AZ cross AY, AZ cross AY will give minus AX. AX cross AZ, AX cross AZ will give minus AY. Minus AY. We can write it by this way also. AX is 1, 0, 0. AY is 0, 1, 0. Multiply them. It will be, all the multiplication will be 0 except AX cross AY. Here it will be 1. 1 times 1 is 1. And we have here X and here Y. The result will be in the Z dimension, so we write it in the Z dimension. So it is AZ. AZ. Application of the cross product. The first one, the magnitude of A cross B give us the area A cross B give us the area of the paralleloid formed by A and B. So the magnitude of this vector is equal to this area here. Second application, A cross B gives us a vector normal to both A and B. So let's go to the exercise. We have vector E and vector F. Determine a unit vector perpendicular to both E and F. So the cross product gives us a vector perpendicular to both E and E. Then we will find the unit vector from it. E cross F cross F. Just let me take this figure. Will give us a vector here. Just let me take this one. Don't multiply the same dimension, x into x or y into y or z into z, because they will give 0. Multiply the different dimension. 0 times y, x into y will give positive z. 0 times y minus 10, it is 0 minus, so here it will be minus 0 times 5, x into z. X into z will give minus ay, so 0 times 5. Now 3 times 4, y into x. Y into x will give minus az. 3 times 4. Now 3 times 5, y into z, so it will give us positive ax. 3 times 5. Now the z into x will give positive ay. 4 into 4, positive ay here. 4 into minus 10, z into y will give minus ax. Here minus ax, 4 multiplied by minus 10. Just remove this one, they are 0, and this one, here it is 4 multiplied by 4 is 16. This is 15. 4 into minus 10 is minus 40. So 15 minus 40, it is positive 55. Minus 3 into 4 is minus 12. So this vector is perpendicular to both E and F. Find the magnitude of it. So we find the unit vector later. The x component square plus the y component square plus the z component square. 55, 16, 12. 55 square plus 16 square plus minus 12 square, which will give us square root of 34. It is 58 for B. So divide this vector by its length. Just take this one. The unit vector of E cross F is this vector divided by its length. The area of the parallelopipe made by E and F is the magnitude of the cross product. So this is the area. That's it for this lesson. Don't forget to solve the exercise.